Good evening, everyone. Am I audible?
Yes, ma'am.
Yes, ma'am.
Okay,
Yes, ma'am.
clear, right? Like loud enough. Okay, so I guess let's begin then. Uh, so how is Maths 2 going on?
It's going well, ma'am.
Yeah, so far so good. Uh, so today, tomorrow is the deadline for week 1, right? So we'll quickly go through doubts of week 1, whatever doubts you have, and then yeah, and if you have any doubts and concepts as well, you can ask. Um, so we'll start off with doubts straight away, or is there some concept that's needed to be clarified? No doubts, in the sense, no conceptual doubts. Okay, great. So maybe I'll just do a quick recap of what is there in week 1. So what are vectors? You would have, is my screen visible?
Yes,
Yes,
Yeah.
ma'am.
Okay.
Yes, ma'am.
So what are vectors in R2, R3, and all that? You already studied, right? Can someone answer? No one? Okay, is this because this is my first session and there's a starting trouble or something?
It's a list, ma'am.
Yeah, so vectors in R2, two-dimensional vectors are nothing but points in the plane, right? Any x comma y. These are the vectors for us in R2. And if it's in R3, then it's in three-dimensional plane. So it has three components. In R2 means it will have two components, an x component and a y component. In R3, it will have three components, x component, y component, and z component. So they'll be points in space. So R3 is space for us, and R2 is plane. So why we are calling them vectors? Yeah, obviously in physics you would have studied them as vectors with a magnitude
Quantity
and
having a
direction.
direction.
Yeah, in physics that's how we have seen it. But in this course, for us, vectors just means elements of a vector space. So elements of a vector space. And vector space, this is the concept that we will be studying starting from week 3 up to week 8. So this comprises the major portion of the syllabus. So elements of a vector space are called vectors. That's all. So for us, vectors means they are going to be some points in R2, a point in R2 or some point in R3. So the domain, the space that we are talking about will be clear from how many components are there in the vector. And for us, vectors, they are just elements of a vector space. So things will be clearer when we get into week 3. But for now, let's just think of vectors in R2 and R3. That is things we can see. R2 is the plane and R3 is the space. And if you take any two vectors, then you add them component wise. Take two vectors in R2, you add them component wise. And what else? We know how to multiply a vector with a scalar. Scalar means real number. Scalars are real numbers. So if you multiply a vector with a scalar, that multiplication happens component wise again. So this is the usual way of how you add two vectors in physics when you studied as well, and how you multiply a vector with a scalar and all that. So yeah, this is the basics of vectors. And once we know vectors, we can talk about matrices. What is a matrix?
It's an array of real numbers.
Yeah, it's nothing but an array of numbers arranged in rows and columns. So you have some rows, some columns, and then you arrange some numbers 1, 2, 3, 4, 5, 6. Then it's a matrix. So what is the order of the matrix? How do you write the order of a matrix?
Number
Rows
of
cross
columns.
Rows by columns.
Yeah, the number of rows comes first, cross the number of columns. So if it is of m cross n, then it has m rows and n columns. So this matrix has 2 rows and 3 columns. So the order of this matrix is 2 cross 3, 2
2
by
cross
3.
3.
So 2 by 3 matrix. Yeah. And the first entry, because it comes in the first row and the first column, it is the 1-1th entry. 1-1th entry. Like that, the position of the entries of the matrix depends on which row and which column they occur in. So yeah, that's how we denote the entries. And if I write a matrix A, then I can in general call it A, I, J, where I and J can be anything. I will vary from 1 to the total number of rows. So for this matrix, I will vary from 1 to 2 and J will vary from 1, 2 and 3. So this is how we denote the entries of a matrix. So what is A 2, 3 for this matrix?
6.
6.
Yeah, A 2, 3 is 6 because the element in the second row and the third column. Second row, third column. The intersection is 6. So 6, the entry 6 is denoted by A 2, 3. And when can you add two matrices? Can you add any two matrices?
No.
Only when they're of
No.
the
Only if
same
the
order.
order is same.
Order is same.
Yeah.
The order is
Order
same.
has to be
It should
same.
have same dimension.
Yeah. So if two matrices have the same order, then I can add or subtract them. And how we add and subtract is we do it entry wise. So we can think of a matrix as a set of vectors as well, right? So I can think of 1, 4 as a vector, which is put as the first column of the matrix A. And 2, 5 is a vector, and it is in the second column of the matrix A. So yeah, where do these vectors belong to? R2, R3, R4. How many components does these vectors
R3,
have?
ma'am? Or R2? R2?
R2. Yeah, when we look at them as columns, then they belong to R2 because each vector has 2 components. But at the same time, I can also look at them as row vectors. That is, I take a row and then I see that as a vector. So 1, 2, 3. Because there are 3 components, whenever I pick a row, it is going to be in R3. So row vector, if I consider row vectors, it's nothing but they are also called row matrices. That is, they have a matrix which has just one row. It is of this form, 1 cross n. It has only one row. So if I have a 1 cross 3 matrix, I can also see it as an element of R3, right? Because that one row is going to, if I look at that as a vector, I'm going to have 3 components. Say 1, 2, 3. This is a row matrix. I can think of this as a vector 1, 2, 3. So how many ever columns this matrix has, so many components that vector will have. Is this clear?
Yes, ma'am.
Yes, ma'am.
Yeah. What about column vectors? What are column vectors?
1, 4,
Yeah, for this matrix 1, 4, 2, 5,
2,
3,
5,
6
3,
all
6.
are, yeah. Column vectors are also called column matrices. They are nothing but matrices with just one column. So it's going to be of this form, m cross 1. So where will this vector be? Means if I think of that as a vector, in which space will it be?
R2.
For this matrix in R2, in general, if I have an m cross 1 matrix, it is going to be in Rm. But mostly we'll be dealing only with R2 or R3. Very rarely we'll go beyond that, but still it's better to know in general. Rm means it's a vector which will have, it is a set of all vectors with m components. That's all.
Ma'am, suppose if R power is something more than like 4, 5, then how will we represent it in the number line that we can
We
plot?
cannot see, right? We can see only up to R3. Space,
Yes,
we are
ma'am.
limited to space. Yeah. So R3, when we talk about like real life applications and all that, since we are seeing it in space, it's up to R3. But if you want to say add X, Y, Z and then a time as dimension, then that becomes 4 components, right? So in
Yes,
some
ma'am.
sense, we can talk about general Rn, but we can see only up to R3.
Ma'am, if the matrix has only one row, like the one you have written here, 1, 2,
Huh.
3. So in this case, what will be the column vector? Like just 1, 2, or 3, or
Yeah,
like,
the column entries, if you want to take the column entries of this matrix and treat them as vectors, they will all be real numbers, right? Only
Yes,
one
yes.
entry, so they'll be
Yes.
in R. They'll be
Okay.
scalars, basically.
Okay. Chick.
Okay. How can you multiply any two matrices?
Yes, ma'am.
No.
Yes, ma'am.
No, ma'am.
Not always, right?
No.
Yes.
Mm.
So when is it possible?
Once
When
column
the number
Number of
column
columns
and
are
the column
sorry.
vectors of one matrix is equal to the number of rows of another.
Of the second, yes. So the number of columns of the first matrix should be equal to the number of rows of the second matrix. So if these two are equal, only then you can multiply these two matrices. And what will be the order of the resulting matrix?
M cross P.
M into
M
P.
cross B.
Yeah, you just take off the common entry and then whatever is left. M cross P will be the order of the resulting matrix. And if AB is defined, should BA be always defined?
Not
always.
necessary.
Not
No.
necessary.
Again, it is all based on you have to check for the columns of B whether it is equal to the number of rows of A, and if that is happening, then BA will be defined. So AB is defined need not imply BA is defined. So obviously these two need not always be equal. There are cases when they are equal, but this is not true in general. Then what is the transpose of a matrix?
Interchanging rows into columns.
Number of columns.
All ijth entries will be changed to jith entry.
Yeah. So you just interchange the rows and columns of a matrix. So we had this matrix 1, 2, 3, 4, 5, 6. What will be the transpose of this matrix? What will be the order of the transpose first of all?
3 cross
3
2.
by 2.
Cross 2.
Yeah, it will be 3 cross 2 because we are interchanging the rows and columns. Then we put the first row as first column, second row as second column. So it's going to be a 3 cross 2 matrix. So if A is of order M cross N, A transpose will be of order N cross M, and that will be equal to A J I. Instead of A I J, it will be A J I. Can you please mute if you're not talking to me? Okay.
Hello,
Yeah.
madam.
Yeah.
That column vector you explained, it should be R square. Means in a case of row matrix, you written R cube, means R3.
Sorry, can you please repeat that?
In column vector, you explained above, it should be R2.
Yeah, I was writing in general M cross N. If I have an M cross 1 matrix, that's going to represent a vector in Rm. In the example that we have taken, it's 2 cross 1, and so it's R2. Right.
Okay.
Yeah. Okay, so any question on what vectors are, what matrices are? Anything from activity, practice, you can ask anytime.
Ma'am, I have a question. May I
Yeah.
ask?
Yeah, sure, please.
Okay. In week 1, in a portal, we have given week 1 tutorial 7. So, sir didn't solve the final values for P, Q, and R. So, as far as I have learned about till 12th standard, are we supposed to pre-multiply by the A inverse to get the values of P, Q, R on the both
Okay,
sides?
is it necessary that A inverse exists for all matrices?
But we could check, right? If the determinant is not 0, then A inverse should exist.
Yeah, that is right. But Okay, maybe in that matrix it exists. I don't know.
Because
Yeah,
sir
it
didn't
looks
solve
like.
it like that. Sir didn't solve it, and
Huh?
uh, some concept of this vector space and vector is quite different from what I studied in 12th. That's why I'm
Hmm.
just confirming it through you. Are we supposed to
You
play
can,
multiply
you
both
can
sides?
multiply by inverse. If the inverse exists, you are allowed to multiply. You'll be studying more methods in week 2. So,
Cause we have a similar question in graded assignment. That's why I'm asking.
you can solve it in any way. You can even do the trial and error that we do in school, no? Like x plus y is equal to 1. Not trial and error, what? Elimination and substitution. So we'll eliminate, we'll add and then eliminate. 2x is 2, x is 1, and then go back and substitute, y is 0, right?
Okay, we can operate on those linear equations.
Yeah, yeah, you can do it however you want.
Okay, ma'am.
You just asked to solve, that's it. So it doesn't matter. Okay.
Excuse me, ma'am.
Yes. Yeah.
Can you take example of determinant to find determinant? Too much
Yeah.
confusion.
I'll just quickly recall everything else, and then once we get to determinants, I'll do that.
Okay.
Yeah. Okay. Then comes system of linear equations, right? What is system of linear equations? What is a system of linear equation? What do we do? Means what is system
It's a
of linear?
collection of
Huh.
it's a collection of linear equations.
Yeah. You have a set of linear equations, and then you want to solve them simultaneously, right? That is, you want to find one common solution to a system of linear equations. So something like I wrote, x plus y is equal to 1, x minus y is equal to 1. Now, if I want to look at this equation separately, then can you tell me a set of points which satisfies this equation?
1 0
1 by 2,
0
1 by
1
2.
2
1
minus
0,
1.
1 by 2, 1 by 2,
0 1.
0, 1.
2 minus 1. Right. So you've already given so many solutions. If I just consider this system. Now consider this one alone, x minus y is equal to 1. Then
2,
can you
1.
give me some solutions?
2,
6
1.
5
2, 1. Then what was
6
it?
and 5.
6 and 5. Yes. So you have a
1 0.
set of solutions which satisfies this equation. Now does this 2 1 satisfy the first equation?
No.
No, ma'am.
Does this 1 0 satisfy this?
Yes.
Yes.
Both
It
equations.
satisfies. Does half satisfy the second?
No, ma'am.
No,
No.
ma'am.
No. So if we are going to look at common solutions, then that's going to reduce. The number of solutions is going to reduce. So what does a linear equation represent? Linear. Why is it called linear?
Because its power is 1.
Huh.
It represents a straight line or a plane.
Right. Perfect. So it represents, if I have two variables here, I'm talking about only x and y. So I'm in R2. So in R2, this x plus y is equal to 1 is going to represent a line. And x minus y is equal to 1 is going to represent some other line. So x minus y is equal to 1 will be 0, comma 1 and minus 1, comma 0. So it is going to be this line. So I have two lines. So what are the possibilities? Now I have two lines. So what are the possibilities? Can they intersect? And how many different points can it intersect?
At
If,
1 point.
if it intersects, it will only intersect in one point.
Right.
It will either intersect at one point or there will be
Infinitely
infinitely many
many.
points, like they are concurrent.
Or they will
Exactly.
be
Oh,
parallel
I
to each
mean
other.
coincidence.
0 1 and
Yeah, coincident. Yeah.
Excuse me,
So you
ma'am.
can either have two parallel lines, in which case they won't intersect at all. If they intersect, they can intersect at exactly one point, or they are both one and the same line. So when they are parallel, we have no solution to the system because they are never going to intersect. And the points that intersect will be the points that lie on both the equations, right? So that's what we are looking for. Solutions means we are trying to look at the intersection points. Now, if they intersect at exactly one point, we'll have a unique solution. And if they lie one on top of the other, we'll have infinitely many solutions. So there is no way I'm going to have exactly 2 solutions or exactly 3 solutions or anything like that. So when we solve a system of linear equations, you can either have no solution or a unique solution or infinitely many solutions. So yeah, we will be seeing a lot of methods to see uh, to solve a system of linear equations, not just in R2, in R3 as well. But yes, before trying to solve, let's write it as a matrix form. How do you represent a system
Excuse me,
of
ma'am.
linear equation? Yeah.
Yeah, ma'am, I just wanted to ask, like, won't we be having problems given and peer tests to solve for stats 1
No,
and max 2?
we don't do that in math 2. Yeah, you used to do that in math 1, right?
Yeah, right.
We don't do it in math 2. So in math 2, what we do is we will first
Divide.
explain the concept and
Okay.
then take doubts. We will solve problems as well. In the sense, I will solve on my screen, you will solve it in your notebook. It's like that. We don't do
Okay.
that common thing. Yeah.
Even the
And
same thing goes for stats 2 as well. I mean, like the same concept will be discussed and problems. Any
I
doubts?
don't know. I don't know what they
Okay.
do in Stack 2. Yeah.
Okay. Okay.
Hello,
Thank you, ma'am.
madam. If we have three equations and
Yeah.
we write two lines are intersecting each other and one line is not intersecting them, then what can we say about
I'm not
that?
able to hear you clearly. Can you speak a little
Hello,
louder?
madam. Am I audible?
Yeah, yeah.
If you have three questions and in that two lines are intersecting each other, and one line is not intersecting them, then what can we tell about such system?
This system, right?
No, means one line
Every
is
two lines intersect, right?
huh.
Huh. So these two lines intersect here, these two lines intersect here, these two lines intersect here. But then when I talk about the system as such, do all the three lines intersect at one point?
No.
So there is no solution. Because only if they intersect at one point, one common point, then it means that that point lies on all the equations, right?
Yes.
Yeah. So in this case,
Ma'am,
there is no solution.
ma'am, to
Yeah.
get this solution or to know how many solutions the equation have, each time you have to draw the graph.
No, 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 no. So you will learn methods to find out number of solutions. In fact, all the solutions also. So you needn't draw the graph. I just drew it. Means when it's when it is x and y alone, you can draw lines. But when you have x, y, z, you're going to have a plane, right?
Yes,
So
ma'am.
yeah. So in that case, it's not easy to draw always. But in GeoGebra, you can plot and see how they intersect and all that. That will be interesting.
Okay.
Okay, so suppose I have two planes, say x plus y plus z is equal to 1, x plus y minus z is equal to 0. Suppose I have two planes, what are the possible solutions? How many solutions can I have?
I'm saying,
The same
I mean,
three?
Can it have a
possible
unique
things.
solution?
Yes.
Yes, ma'am. I mean, three
How
types
come?
of
No,
solutions you
ma'am.
can get.
Infinite solution.
Huh. So if the planes are parallel to each other, then they are parallel. No solution, right? Okay, I'm drawing in 3D, so you assume this is parallel, okay? So if they are parallel, then there is no solution. But if they intersect, how are they going to intersect? Will they intersect at exactly one point?
No. They will
No,
make a
they will
line.
intersect at a line.
Yeah. So when they intersect, it's going to be along a line that they intersect, right? So if you have just two planes, you will either have no solution or you will have infinitely many solutions. But now suppose I introduce a third plane. Something like this. I introduce a third plane, then it is possible that they have a unique solution, right? They can intersect at exactly one point and all that. So,
Hello, madam. I
yeah.
don't understand. Three planes intersect at one point.
So, okay, let's open GeoGebra. My screen is visible, right?
Yes, ma'am.
So say I have x plus y plus z is equal to 1. Did the plane come? Yeah. So this is the plane. And then say I have x plus y minus z is equal to 0. Okay. So now can you see that when I have these two planes, they are intersecting. So definitely there is a solution. And they are intersecting at along this line. All these points are points of intersection. So if I have a system of linear equations with these two equations, I'm going to have infinitely many solutions. Is it clear?
Yes, madam.
Ma'am.
So now let's add x minus y plus z is equal to 0. These planes don't intersect. Is it clear? So maybe I'll change the color. So is it clear that, or are they intersecting? Oh yeah, they are intersecting. Can you see that there is exactly one point where all three of them intersect?
Yes, ma'am.
Yes, ma'am.
Yeah. So now let's put that's fine. So now if I have these three equations, so you can see that these two planes intersect. These two planes intersect. Equation 1 and 3 intersect. Equation 1 and 2 intersect. But all three of them don't intersect at the same point. Right? So in this case, again, we don't have a solution. So is the unique solution part clear? With the one previous example that we saw. X minus y plus z is equal to something like this. So here there is exactly one point of intersection. So in whatever way you see, there is exactly one point in which all the three planes intersect. So these two planes intersect along this line. These two planes intersect along this entire line, but all three of them together intersect exactly at one point. That's a unique solution case.
And if the number of variables is 4 and the number of equation is 2, then how can they intersect? I mean, what are the possibilities?
Why don't you guess?
I think they will intersect at line.
No, you have 4 variables
Yeah.
and 2 equations. So here
Yes.
we had 3 variables and 2 equations. So it was a line. So what will it be there? It will intersect in a plane, right?
Plane.
Yeah.
And if the number of equations is 3,
then you will get line option.
Okay.
Yeah.
Okay.
So that was a good question actually. So that's somewhere towards where we are trying to go by the end of week 2. So yeah, that's good. Okay. Then just give me 1 second. Yeah. So yes. So is it clear geometrically what system of linear equations is and all that?
Ma'am, I have a question.
Yes, please.
Ma'am, all two planes always intersect along with a line, and three planes always intersect in a particular point.
No, not necessarily. No, we saw examples where that was not happening, no? If I change this to minus. I gave an example where they were not intersecting at all, no?
If they
This
intersect, if they intersect.
No, these two planes can be the same, no? Like I write the same equation. I have three equations, out of which two of them represent the same equation. Then also I have a line of intersection, right?
Okay.
Yeah.
Okay, ma'am. Thank you.
Okay. Yeah. So how do we represent a system of linear equations in the matrix form? The matrix form of a system.
Ax is equal to b.
Yeah. So what is A? What is X? What is B?
A is
the
matrix,
coefficient of
X is variable.
equations.
So if I take this system, I have two equations and three variables. So the number of equations represent the number of rows and the number of variables represent the number of columns. So 1, 1, 1, 1, 1, minus 1. And then my x will be the vector x, y, z. And b will be the vector 1, 0. Right? So this is the coefficient matrix. This is the vector of variables. And this is the right hand input vector that's given. Right? So if this is m cross n, then the variable vector will be n cross 1 and the resulting vector will be m cross 1. M will denote the number of equations, n will denote the number of variables. Clear?
Yes, madam.
Okay. So any questions on this? I think we have covered videos 1 and 2 in this. Any questions in activity? Yeah, we've covered all this.
Ma'am, I have a question. Oh, that's the determinant part. Sorry.
Okay, no problem. So this question in activity, what is this trying to tell actually? So you would have already solved this.
Which option are you asking about?
In general, this problem, what is it trying to teach you? Okay, let's take the first one. A squared is equal to I. Then A is equal to I and A is equal to minus I. One of these must be the answers. Is the first option correct or false?
False, ma'am.
False.
False. Can you give me an example of a matrix which does not A squared is equal to I, but A is not equal to I or A is not equal to minus I.
We can take an example as 0, 1, 1, 0.
0, 1, 1, 0.
1, 0. Yeah.
Okay. Does this give? Yeah, I think this is 0, 1. Yeah. Fine. Perfect. So actually, in general, what that example, that question is trying to tell is matrices don't work like numbers. That's what it says. See, for example, a squared is equal to 0. We have a squared is equal to 0, but that's not necessarily mean a is equal to 0, right? But when we have numbers, this holds, right? If I have a number x squared is equal to 0, then we know that x has to be equal to 0. And if I have two numbers that multiply to 0, then I know that x is equal to 0 or y is equal to 0, right? All these don't hold for matrices. AB is equal to 0 does not imply A is equal to 0 or B is equal to 0. Fine?
Yes, ma'am.
Yes, ma'am.
Yeah.
Ma'am, I have a question.
Yes.
If it is a identity matrix and if square it, how it is changing?
No. You're asking this one, right? This question, right?
No, I'm asking about the identity matrix itself. How it
Okay.
behaves if it is a square or it is a cube. So, how the value changes?
No, the values don't change. No, identity matrix, whatever power you take, you're going to get back the identity matrix. Any power.
Okay, so all I will be the same, no matter what power we have.
Yeah, 1001 power n is going to be 1001. In fact, if you have a diagonal matrix A00B, what is the square of this matrix?
I guess same, ma'am.
Same.
2
No, how will
times
it be the same?
A00B. 2 times.
No, ma'am.
How
Ma'am,
will it be 2 times?
Then we can say like that, no? 2 into 2 times A00B.
No.
No, ma'am.
You
If we
multiply
just
the matrix with itself.
Okay.
A times
A
A.
square 0, 0 B square.
Huh. So what do you think the cube will be?
A square into A.
Right. So that's
A cube 0.
0, 0, B cube.
Yeah. So can you see the general pattern?
Yes, ma'am.
Yes.
C A power
So if
n
you
0,
have,
0 B power n.
yeah. So if you have any diagonal matrix, its power is easy to calculate.
Hello.
Yeah.
Ma'am, here in A square, this element 1 in first row, second element should be AB, not 0.
No, no. A into A plus 0 into 0. A into 0 plus 0 into B. So 0, no?
Okay, okay. So,
yeah. So when you have diagonal matrices, it is very easy to calculate the power. You just put the power along the diagonals. So now is it clear that when you have identity matrix, whatever power you take, it's going to remain identity?
Yes, yes, ma'am.
Yes.
Yeah. So you put A is equal to 1, B is equal to 1. That's all.
Okay.
Okay. Then what else? Is this question clear? The seventh question?
no, ma'am. 6th and 7th question, not really.
Sixth one you haven't understood yet?
Yes, ma'am.
Okay.
No, 6th, 7th.
This is fine. Okay, fine. So one thing that you have to keep in mind throughout the course, not only throughout the course, for any course, in fact, if something is true, you have to prove it. You cannot take an example and say that because it is true for this example, it is true in general. You cannot do that. But when something is false, it's enough if you give a counter example. Counter example means one example for which that statement is not true. Then that statement becomes false. Right? So when you have to prove something, means when something is true, you want to say something is true, you have to prove it. You cannot choose some particular matrix and give an example. You have to take, like for example, if I ask you for a diagonal, the square of a diagonal matrix is the diagonal matrix whose diagonal entries are the square of the diagonal entries of the original matrix, if I say, then you cannot say 1002 squared is equal to 1 squared 002 squared. This is not true. Means this is, yeah, this is true, but this is not going to tell that for any diagonal matrix it is true. Instead, you should take in like any general diagonal matrix. So any general diagonal matrix is going to look like A00B. Then you find the square and then you show this. But if something is false, you can give an example like this.
Yes, ma'am. Actually, you wrote A to the power n and B to the power n, no, ma'am, for the above question. And it is only for diagonal matrix, right, ma'am? It is not for all the matrices.
Yeah. This is only for diagonal matrices. Yes.
That's what. Okay, ma'am.
Yeah. Okay, so let's do that seventh one. If A is a square matrix of order 2, whose first column is denoted by C1 and second column is denoted by C2, and B is this. Okay, the first column of AB is, okay. So we have A, which I denote by C1, C2. So C1 is the first column of A. So B is B11, B12, B21, B22. So how many components should each column of C have?
Two.
So how many columns does it have? It has 2 columns.
Two.
And this has 2 rows. No, it can have anything, right? Like it doesn't matter, no? Because this matches, right? Even if it was 3 cross 2, there was no problem, no?
Ma'am, in question it's mentioned that it's a.
It's given.
Okay, fine. But in
given.
general, I'm telling if it is not given, it can have any components, right? It doesn't matter. Because it has 2 columns and B has 2 rows. Then that's what we want. Okay, anyway, because it's given in the question and it's a 2 cross 2 matrix. So C1 is a vector with 2 components. C1 is going to look like what? Say A11, A12 or A21. C2 is going to look like A12, A2. And now the question is, what happens to AB? AB is what? A11, A21, A12, A22, B11, B12, B21, B22. So when I multiply, I'll get A11, B11 plus A12, B21. Write it below. And then A11, B12 plus A12, B22, A21, B11 plus A22, B21, A21, B12 plus A22, B22. Now, the question is in terms of B11, B21 and all, and C1 and C2. So I want to write it in terms of C1, C2. So C1 is A11, A21. Can you find out A11, A21 common somewhere? Here and here, right? Yes?
Yes.
Yes,
And
ma'am.
similarly, C2 can also be found here and here. So now this matrix I can write as sum of these 2 vectors. So when for the C1 here, the C1 vector, we have a common coefficient B11. So it's B11, C1. B11, C1 means what? B11 is a number, C1 is a vector. So I will multiply each component of the vector C1 with B11, right? A11, A21. Can I write it like this? The first entry here and the first entry. Yes. And for this entry, it's going to be, this is what? C2.
B21.
B21 is common, and then C2, A12, A22. Now this is the first column of AB. I haven't written AB fully. This is the first column. Second column, similarly, I can write it as B12, C1 plus B22, C2. So with this, can you answer the options? It's just a different way of expressing the product. Is it clear? The person who had the doubt, is it clear?
Yeah. Yes, ma'am.
Okay.
It's little confusing. I will try again.
Yeah, you just write it down and then you will be able to get this.
Ma'am.
Yeah.
Ma'am, I have the doubt in the previous question, 4th option.
Okay. If A is a scalar matrix of order 3, what is a scalar matrix?
All the entries are equal to a scalar multiple.
All the diagonal elements are equal.
Diagonal entries are equal.
Yeah, it is a diagonal matrix with same diagonal entries. So a scalar matrix can be written as alpha times identity matrix, right?
Yes.
Yeah. So you have a scalar matrix and then you have a non-zero square matrix of order 3 and then you multiply both, you get 0. Okay. So you have, let's take 2 cross 2. to avoid too much computation, let's take 2 cross 2. And then I have, say, B, C, D, E. B is a non-zero matrix. What is a non-zero matrix?
All components are not zero.
No,
The diagonal numbers.
no.
None of the entries are non-zero.
Only one.
No. What is a zero matrix?
All
What does
components
the
are
entries
zero.
All
are zero.
components are zero.
So what is a matrix which is non-zero? It is not the zero matrix. That's all. So if you have a matrix with at least one non-zero entry, then it is a non-zero matrix, right? Because if it has even one non-zero entry, it is not the zero matrix. And if it is not the zero matrix, you call it a non-zero matrix, right?
Yes, ma'am.
Okay, yeah.
So either B, C, D, E, any one of them is non-zero is enough for me. So now let's multiply and see what do we get. A times B, A times C, 0B, AD, and then what? 0C, AE. Now I am given that this is equal to 0. So I know AB is equal to 0, AC is equal to 0, AD is equal to 0, AE is equal to 0. What can we conclude from here?
A or B can be zero. A or C can be zero. Either one of them is zero.
A is 0 or B is 0. Similarly, here A is 0 or C is 0, A is 0 or D is 0, A is 0 or E is 0. But, okay, now I know that this is a non-zero matrix, right?
A is 0.
So say if B is non-zero,
A
then
should
that
be
gives
0.
me A is 0, right?
Yes.
Yes.
And if A is 0, what happens to this matrix?
Zero matrix.
Yeah. So because at least one of these entries is non-zero, using that condition, whichever entry is non-zero, using that condition, I can conclude that A has to be 0. Is it clear?
Yeah.
So
Yes,
A is
yes, sir.
0, the matrix itself is 0. The matrix A is 0. This is only because it is a scalar matrix. If it was a diagonal matrix, we cannot tell this. Means if you are allowed to change the diagonal entries, you cannot tell this. So now because I'm proving that the statement is true, I'm taking a general matrix. You see, I didn't choose a particular example. If it was false, I could have just chosen some random example. Clear?
Yes, ma'am.
Yes, ma'am.
Okay. So I guess we are done with this lecture, okay? And what happens in 1.3? So this matrix representation we discussed, unique solution, no solution and all that. We know how to do. So is there any doubt in this activity?
Hello, ma'am.
Yeah.
Can you scroll up to the left? That plain sum is there. No, I couldn't understand that sum. I just joined
This
now.
one.
Yes, this one.
Okay, so you're given two planes, you're asked whether they have a solution or not, right? The above system has, So, do they have a solution?
I couldn't.
When will you
No.
say they have a solution?
When they intersect and when they are go in a same line, both the
Right.
lines.
Do they intersect? Are these two planes intersecting?
No, it's not.
Yeah, they're parallel, right? So they don't
Yes.
have a solution.
Okay.
No solution. Yeah.
Thank you.
So something like this. You have only these three cases. Parallel means no solution. They intersect at exactly one point means unique solution. They lie one on top of the other. That is infinitely many solutions.
Okay, ma'am. Thank you.
Can you please scroll up to that question?
Plain
Please, yeah. Even if they intersect, then it will have, I think, infinitely many solutions.
Right. If they intersect, yes, because we have only two planes, they will intersect along a line. Right.
Yes, exactly.
Maybe we will do this seventh one because a lot of people had asked on this course. So it's given that
Yes, ma'am.
x1 and x2 are solutions of ax is equal to b. So you have a system ax is equal to b, and you are given x1 and x2 are solutions. So when do you say something is a solution to this?
When LHS is equal to RHS, when we put that into X.
If it satisfies the equation.
Right. So A is given, B is given. What we have to find is X. So once we find X, if we plug it in and if it satisfies, then it is a solution. So if X1 is a solution, what do we know?
X1 is equal to B.
Right. Ax1 is equal to B, and if x2 is a solution, we know Ax2 is equal to B. So options are all about x1 plus x2. So I want to check whether x1 plus x2 is a solution of Ax is equal to B. So if I want to find out whether it is a solution of Ax is equal to B, what should I check?
A times x1 plus x2 is equal to b.
Right. If I want this to be a solution, I should put this in the place of x, and I have to check whether it is satisfied. So what is A times x1 plus x2? Ax1 plus Ax2, right?
Yes.
But we already know Ax1 is B and Ax2 is B. So this is equal to 2B. So this is not true, right?
Yes.
It will be true if B is equal to 0, but in general it is not true. Is it given B is equal to 0? No. So in general it is not true. So x1 plus x2 is not a solution of Ax is equal to B, but it will be a solution of Ax is equal to 2B. Similarly, you can subtract. When you subtract, you will get 0, right?
Yes, ma'am.
Yeah.
Yes, ma'am.
Like that, in the 8th problem, we have two different systems, two different matrices altogether, but same solution we are talking about. Okay, fine. Now determinants. Okay. Can you find the determinant of any matrix?
No, ma'am. It
No,
has to be
only
square
square
matrix.
matrix.
Right. So you can find determinants only for square matrices. If you have rectangular matrices, you cannot find the determinant. How will you find the determinant of a 2 cross 2 matrix?
AD minus BC.
Yeah, so the determinant of this matrix is AD minus BC. So this is the only thing that we have to remember, and every other determinant formula is built on this. So if you have 3 cross 3, you will try to convert it till you reach a 2 cross 2 form and then find the determinant. So that and all is discussed in week 2, I guess. What is there here? Things like this. The properties of determinants. Can you tell determinant of A plus B is equal to determinant of A plus determinant of B?
No, ma'am. Not
No.
always.
No. So this is not always true. What about the product?
Yes, ma'am.
Determinant
Yes,
of
ma'am.
A into determinant of B.
It's correct.
So the product is true. And then what else? Determinant of A transpose. What is the determinant of A transpose?
Determinant of
Determinant of A.
Yeah.
Whole transpose.
No, determinant is a number, right? So the transpose of a number is the number itself, no?
Okay.
So the determinant of a matrix and its transpose are the same. Then what else is there?
Is the determinant of AB is equal to determinant of BA?
Yeah, that's because determinant of AB can be written as determinant of A into determinant of B. This
So
can
that's
also
why.
be written as determinant of B into determinant of A, right?
Okay.
Yes.
And this can be written as determinant of BA. Because you're allowed to multiply two numbers in any order you want. Then what else?
Determinant of A inverse.
So is the inverse concept in week 1 already?
But one question is there, ma'am.
No,
Okay.
ma'am. Inverse is in week 2.
Okay, anyway. So if the determinant of a matrix is not equal to 0, only then we can talk about A inverse. And determinant of A inverse, what is the determinant of A inverse?
1 by determinant of A.
Yeah, it's 1 by determinant of A.
It's there in practice assignment, ma'am.
Okay, fine. And then expanding. Okay. So how do we check the determinant of a 3 cross 3 matrix? So I have A, B, C, D, E, F, G, H, I. How do we expand and find the determinant? Is there a question? Okay, fine. So how do we find the determinant in the 3 cross 3 case?
Ma'am, we can find it by taking minor and cofactor.
Yeah, you can do it by finding minor cofactor, but that's week 2 content, right? Because in this week we are expanding only along the first row, I guess. Right?
No, ma'am, it's been there in the week 1, last lecture.
Oh, okay, fine.
Ma'am,
then what is
there's a question, activity 1.39 question.
1.39 question. Okay, consider a system of equations. If K has if system has a unique solution, then K should not be equal to. Okay, how will you do this?
My answer was 9, and that answer is -9. I don't know why.
Because there it's plus K. You want -3, no? So -9, right? The system has a unique solution. You're multiplying. How do you get the second equation? Are you multiplying by? Right. I'll write that. Can you just quickly tell me the equation? X1 plus 3x2 is equal to 4. 3x1 plus kx2. Oh, this is minus is equal to -12. Right? 1 minus 3x2. Right. Okay. So, what did you say? Your answer is 9. Okay. Suppose this is 9. What happens? With 9, what happens? You multiply this equation by 3, and you'll get a -9, and then you'll get 12. Then you will, and then when you add, these two will be 1. X1 will be 0. X2 is -4/2. Right? Yes?
Yes, ma'am.
Okay. Now say if your answer was 9. So now say we put it equal to 8. What happens in this case? Again, we'll do the same thing. 3, 9, 12, and then we'll subtract now. So this will be gone. -17, x2 will be 24. So x2 is 24 minus 24 by 17. x1 is equal to something. Again, you're getting a unique solution, right? So why is your answer right and my answer wrong? The question is, K should not be equal to what to have a unique solution, right?
Yes.
So what should it not be equal to? How will you find that out? How will you find that out? So unique solution means what? These two lines are going to intersect at 1 point. You don't want that to happen.
Ma'am, we'll try to make it like a parallel or infinite something.
Ma'am, if it is -9, then it would be parallel.
If it is -9, then I'm multiplying the first equation by 3, right? But then I should have 12. Instead, I'll get -12. No?
So, ma'am, lines would be parallel and there
Parallel.
would be no solution.
Right. In that case, there will be no solution. So yeah, this time you can see it geometrically, but once you know how to solve a system in terms of like in the matrix form and all that, you can tell it straightforward that yeah, this is what is happening, so it won't have a solution and all that. So now is it clear that it has to be -9?
Ma'am, but
When I multiply this equation by 3, I'll get 3x1 minus 9x2 is equal to 12. And my second equation will be 3x1 minus 9x2, because my k is -9, is equal to -12. Can this have a solution?
ma'am, here we already know answer. What if we don't know how to solve it?
So you can use that parallel lines concept. No, parallel lines will have the same slope. So -3 by 1 should be equal to k by 3, right? You want to somehow make them parallel lines so that they don't have a unique solution, right?
Yes,
Ma'am,
ma'am.
Yes, ma'am.
So the
A1 upon
coefficient,
A2 is equal to B1 upon B2 is not equal to
huh,
C1 upon C2. Then that would be have no solution.
right?
By that way, we can answer that the answer should be -9.
Yeah. Fine.
Yes, ma'am.
Oh. Okay.
Ma'am,
How will you
activity 1.4, question number 9.
Okay. Huh. Oh yeah, we didn't discuss this property. Tell me what happens to determinant of k times a. Say I have a 2 cross 2 matrix A, B, C, D. We know its determinant is AD minus BC. And then I'm multiplying this matrix by k.
Determinant also multiply
K square
Determinant will be
by k square.
k square.
Huh.
Be
K square.
the order
So
of
you
the
have
matrix.
k into kd minus kb into kc. So you'll have a k squared common, AD minus BC. So
Yes, ma'am.
from every row or from every column, I can take a k out. So if I have a 3 cross 3 matrix, 3 times it will come out, power 3. So yeah, what is the doubt in this question?
In this question, how to find B inverse, ma'am? In this question, 6A square B inverse.
Let A be a square matrix of order 3 and B be a matrix that is obtained by adding 2 times the first row. A is some matrix. What matrix
Yes.
is not given. B is obtained by adding 2 times the first row of A to the third row of A and adding 3 times the second row of A. What is the value of this? Okay, fine. So tell me what is determinant of 6 times A squared B inverse? How many 6 will come out? Huh.
Into
6
not a.
cube
6 times 6
into,
multiple of 6.
right, 6 cube determinant of A squared determinant of B inverse,
B
right?
inverse.
So 6 cube determinant of A whole squared into 1 by determinant of, right?
Yes.
Because determinant
Yes.
of the inverse is this. Yeah.
Yes.
Okay.
Yes.
So to understand that question, we need to know what the elementary row operations are. Okay. Before we finish, do 3 cross 3 determinant, then let's do what elementary row operations are. What are the elementary row operations?
Interchanging rows and columns.
Row addition.
Interchange
Addition of the row.
rows. Okay, then
Adding one row element to the other.
Determinant takes a negative sign.
Adding the scalar multiplication of one row to another row.
Right. Ri, you replace one row with scalar times that row.
And then
And Ri, you replace it with Ri plus
RJ.
some alpha times R.
RJ. Okay.
Yeah. You can write it as Ri plus Rj or alpha times R.
Yeah.
So you're allowed to do only these three operations, which are called as the elementary row operations. When you interchange two rows, what effect does it have on the determinant?
Minus sign takes place.
Sign is interchange.
Yeah. So you get multiplied by -1. Determinant gets multiplied by -1. When you replace a row with alpha, what happens? Alpha times that row.
Alpha times the determinant of the base.
Right. So you gets multiplied, means the determinant gets multiplied by alpha. That's why here the determinant gets multiplied by k squared, right? Because from this row I can take a k out. From this row I can take a k out.
Yeah.
What happens when you do this operation, third operation?
No changes in determinant.
Yeah.
No change.
No change. And can you see that this is the operation that you're doing in the matrix A to get the matrix B? So adding 2 times the first row of A to the third row of A. That is R3 is replaced with R3 plus 2R1. And what else is done? And 3 times the second row of A to the first row of A. R2 is replaced with R2 plus 3 times R1. So when you do this operation also there is no change. When you do this operation also there is no change. So determinant of B is equal to determinant of A, right? Right?
Yes.
Yes, ma'am.
Now you can cancel it out and you will get 6 cube determinant of A.
Thank you, ma'am.
Yeah. What were we discussing? 3 cross 3 determinants. Yeah. How will you expand
Madam,
3 cross?
can you explain it once again?
Which one?
This one, elementary row operations.
Okay. So elementary row operations are when you can interchange two rows. There are 3 elementary row operations. And the operations are you can interchange two rows, Ri with Rj, or you can replace a row with alpha times that row. So you replace the first row with 2 times the first row. Those are all elementary row operations. So say for example 1, 2, 3, 4. When I interchange, I will do something like this. 3, 4, 1, 2. This is an elementary row operation. Now suppose I replace the first row with half times the first row. So half, 1, 3, 4. This is an elementary row operation that I have performed on the original matrix. And then third one is you replace the second row. Say for example, I replace second row with R2 plus 2R1. So 1, 2, second row is replaced with second row plus 2 times first row. So 3 plus 2, 4 plus 4.
And
Right?
madam, there will be no change in the determinant value.
Yeah. So what is the determinant of this matrix?
-2.
-2. So here I have done first interchange. So what will the determinant here be?
2.
2.
I know because when I interchange two rows, the sign will change. Anyway, if we calculate 6 minus 4, 2. What about here? What should the answer be?
-1.
Yeah. Is it -1? Half times 4, 2, minus 3, -1. And what will be the determinant here?
-2.
Yeah. Is it -2? 8 minus 10, -2.
Thank you, ma'am.
Yeah. So these are the elementary row operations and their effects on the determinant.
Ma'am, in the previous question,
And
was
that
it
-1, which property it makes, like the -1 value, no? Which
I have
property?
multiplied R1 with half times R1. I've replaced R1 with half times R1.
Now, which property is satisfied? Like, because
That determinant gets multiplied by whatever number you're multiplying.
so I
I'm
multiplied by
multiplying
half,
by
but I
half.
got -1, right?
No, this is the original matrix. -2, so it's becoming -1. From this matrix, I went to this matrix. From this matrix, I went to this matrix. Yeah.
And how
Ma'am,
it
in
is
the
done in
previous
3
question,
into 3 matrix?
How did?
How it is done in 3 order matrix?
Same. It's the same concept. 1, 2, 3, 0, 1, 0, 0, 0, 1. Now, what is the determinant of this matrix?
1.
Why?
And
Because it's
for a
upper
triangular
matrix. And
upper
Right.
triangular matrix,
It's an
the
upper
diagonals.
triangular matrix. So product of the diagonal entries is the determinant. So the determinant is 1. So first let's interchange two rows. What will the determinant here be?
0.
-1.
It has to be -1 because I have interchanged two rows, right? But how do you calculate the determinant of a matrix? 3 cross 3 matrix?
by removing corresponding rows and columns and
A, B, C, D, E, F, G, H, I. So what you will do? You will first expand it along a row or a column. Okay, so first we will do it. We will learn expanding along the first row alone. So I am expanding the determinant along the first row. My aim is to split it up in such a way that I will end up with only 2 cross 2 pieces. Okay, so
We can also expand it along the first column. It will be easy for.
right. I'll tell for the first row first. So when it's for the first row, it is plus, minus, plus. So you'll put the first entry, A times plus A times. Remove the row and column where A comes and find the determinant of the 2 cross 2 block. Do you know how to find the determinant of this?
yes.
Yes, ma'am.
Yeah, because it's 2 cross 2, we know how to find the determinant. And then minus B. For the second one, it goes with a minus sign. So minus B, remove the row and column where B occurs and the determinant of the remaining matrix. D, F, G, I. We know how to find the determinant of 2 cross 2 matrix, so fine. Next, C, plus C. Plus C times, remove the row and column where C occurs, D, E, G, H. So this is how you find the determinant of a 3 cross 3 matrix by expanding along the first row.
Okay, ma'am. Thank you.
But it is not necessary that you have to expand only along the first row. Across any row and any column you can expand. The order of the sign is this: plus, minus, plus, minus, plus, minus, plus, minus, plus.
Hello, ma'am.
Yeah.
Can we do it in a diagonal wise? Can we find it? Okay.
Only
ma'am, in the
row wise or column wise.
ma'am, in the
Ma'am,
previous question, that determinant one, which we are doing, like it was given some 6 to the power something. I missed that. Just can you go there? Yeah. Yeah, this one. How, like, determinant of B, we replaced it by determinant of A.
Yeah, that's because we were doing two operations on B, which was like this, and that is not going to change the determinant of the matrix. Means B is obtained from A by doing two row operations of this kind. And when we do row operations of this kind, there won't be a change in the determinant.
Ma'am, can the row operations be done simultaneously?
Yeah, are you asking something like this? R2 is replaced with R2 plus R1 and R1 is replaced with 2 times R1. Something like this?
Yeah, at the same time.
But
not
if you
one after the other.
you can do it simultaneously as long as the same rows are not involved. So you're replacing R1 with 2R1, and then you're doing an addition of R1 also. So which one will you add? Will you add the old R1 or the new replaced R1? So in this case, you should do it separately.
Ma'am,
Huh.
ma'am, could you please expand through another, like, let us say row 3 and row 2, because I got confused about when I expand.
Yeah, we'll do. So
Ma'am,
simultaneous row operations, is it clear? You can do as
can you
long as
mute
no rows
everyone?
overlap.
Ma'am,
Can
can
you
you
please
scroll the
mute if
up
you're not
page of
talking
our
to me?
website?
Okay, fine. Yes. What is the question?
Ma'am, scroll the page for a while. Scroll up, ma'am.
We will.
Just scroll the page up for a while, ma'am.
Okay. Up or down?
Up. Yeah, ma'am. This 6 cube determinant of A. How you done? How you have done this?
So you understood which problem we were talking about? This is one of the activity problems. Yeah. So determinant of B inverse is 1 by determinant of B. Determinant of A squared is determinant of A whole squared. How B is got is given in the question. B is got by performing two operations on A of this kind. This is what is given. And when we do such an operation, is it going to change the determinant?
No, ma'am.
That is why determinant of B is equal to determinant of A. Is it clear?
Yes, ma'am.
Okay.
Ma'am, could you please expand about another row and column?
Yeah. So we take the same matrix. We will expand this we already know the determinant is 1 because it's an upper triangular matrix. So determinant is product of the diagonal entries. Let's expand along the last row. So for the last row, what is the first sign? Plus or minus? Does it start with plus or minus?
Plus.
Yeah, plus, minus, plus. So 0 times, remove the row and column in which 0 appears. Determinant of 2, 3, 1, 0. Oh, when I draw two parallel lines like this, it means the determinant. For matrix, we will put like this, or simple brackets like this. When we don't put that, it's determinant. Okay. Instead of writing determinant every time, this is the notation that we use. And then minus 0 times, remove the row and column in which 0 appears. 1, 3, 0, 0. And then plus 1 time 1, 2, 0. So whenever there is a 0, whenever there are lots of zeros, we can pick that row, right, to expand, or pick that row or column to expand. Because whenever there are zeros, we are multiplying by zeros and most of the terms are gone, right?
Yes, ma'am.
So again here it's 0 into something minus 0 into something. Here 1 into 1 minus 0. So the determinant is 1. Is it clear?
Yes, ma'am.
Yes, ma'am.
So, ma'am,
Okay. Yeah.
can you explain induction property, please?
Induction property. Why?
Because I'm not able to understand that.
Are we using induction somewhere?
Yeah.
No, right?
No, ma'am.
I think it was mentioned in the lecture also, and I'm a bit confused.
Okay,
It's
I'll
not
explain it
property.
at the end of the session.
Yeah.
Sir, actually explain the minor and cofactor method of determining the determinants using the induction method.
Oh, okay. That induction just means that you try to reduce the size till you reach 2. Inductively in the sense. That's not induction, that's inductively, I guess. You do the same thing again and again to break it into smaller and smaller pieces. Is that what it is?
Yes, ma'am. Yes.
Huh. Okay, so suppose I have a 4 cross 4 matrix. Then what will we do? How will we find the determinant? How will we find the determinant?
We find the 3 cross 3 matrix.
Yeah. You again expand along some row or column. So if you want to expand along this row, once you pick this element, you will be looking at a 3 cross 3 matrix. And now we know how to find the determinant of a 3 cross 3 matrix. Go back, split it again into 2 cross 2, and like this you will find out. Like that, 4 different things you will find out. That is what sir would have meant, inductively. That induction, method of induction is something different in mathematics. That's a very basic and important method, but that's not used anywhere in our course.
Okay. I was a bit confused.
Okay, no problem. Okay, so what is a minor? What is a cofactor?
Minor is determinant we get after removing corresponding rows and columns. And cofactor is we multiply it with -1 raised to I plus j.
Right. So minor is, if you have a matrix, you find the minor of some entry of a matrix. So minor of Aij. So minor of Aij is obtained by removing the row and column where Aij occurs and finding the determinant of the remaining of the matrix. So here what are we doing? We are removing the row and column where A appears and we are finding the determinant of this, right? Yes? Yeah. So this is the minor of A. And this is the minor of B, right? Because in all the cases, that's what we are doing. We are removing the row and column in which the number appears, and we are finding the determinant of the left out matrix. And this is minor of C. Is it clear what a minor and cofactor is? A minor is?
Yes, ma'am.
I think this comes in week 2. In case you haven't watched week 2, don't worry.
Oh, ma'am.
And what is cofactor? It's nothing but a
-1 whole to the
Signed
power
minor.
of I plus j
-1 power I plus j
into
the
minor.
minor Aij. That's all. So that is how you get this plus minus plus minus. So the entry, the first entry is A11. So you will do -1 power 1 plus 1. So we'll get -1 power 2. So positive. Next we'll get -1 power 1 plus 2. So this will be negative. Then -1 power 1 plus 3. So this will be positive. So whenever the sum of the indices is odd, you'll get a minus sign. And whenever the sum of the indices is even, you will get a plus sign. Is it clear?
Yes, ma'am.
Yes, ma'am.
Yeah. So that's what minor and cofactor is. And what you're basically doing is you're calculating the determinant by expanding along any row or any column just by using its cofactors. So cofactor we denote by Cij. So A11 C11 plus A12 C12 plus A13 C13. It's a 3 cross 3 matrix. That's it. If you want to expand along a column, it's going to be A11 C11 plus A21 C21 plus A31 C31. Whichever row or column you want to pick, you pick. Multiply each of the elements with its cofactor and then add. Whichever row or column you pick, you will always end up with the same number, and that number is the determinant of the matrix. Is it clear?
Ma'am, I have a doubt about this.
Okay.
If we are able to get the determinant from the first row itself, then why we are why we are doing it for all the rows or any?
No, you needn't do for all the rows. You can pick which row you want. See, for example, if you take this matrix, if I expand along the first row, I'm having 3 non-zero entries, right?
Right.
But if I expand along the third row or the second row, I have only one non-zero entry, right? Because when I'm multiplying with the number also, so I'm multiplying with 0, so I can ignore those terms, right? Computation becomes simpler, right?
Yeah. Okay.
That's
That's why this method is introduced.
yeah. That is why you're allowed to expand along any row or any column.
And -1 raised to I plus j. This deals with signs, right?
Yeah, you're putting a minus sign here, no? Why did you put a minus instead of a plus? You're putting plus here. Why a minus here? That is from that a power -1 power I plus j. Cofactor, no? Signed minor.
Ma'am, activity 1.4, can you explain the third sum?
0.4. So I guess we've covered all the concepts, right?
I couldn't understand that problem.
So let A be a 2 cross 2 matrix which is given by this. Define the following matrices. Which of the matrices have the same determinant? Okay, so you have to see if you're what operations you're doing on A to get B, C, D, E and all that. With that you can tell what the answer will be. Now tell me, how are you getting B?
R1 minus R2.
From A, how did we get B?
Is that R1 minus R2?
Yeah, R1 is replaced with R1 minus R2. If you do that, will the determinant change?
No, it doesn't change.
Yeah, so determinant of A and B
I
are
couldn't understand that the D part and E part, how to calculate. I couldn't. They're taking the column, I think, column and row simultaneously.
And one is plus, one is minus. So you cannot tell anything about that, right?
Yes.
That's not an elementary row operation. So you cannot tell, but you can expand and see what is the determinant. You can do that AD minus BC, and then the determinants won't match.
Okay.
Any other doubts?
Ma'am, I have doubt in the practice assignment.
Yeah, one second. Before that, I'll post a link. Can you please fill that form? Just for this kind of attendance. It will say, what is this? It will say Maths 1 live session, but that's okay. Please fill this form. Yeah, practice it.
Hello, madam. Can I ask a question?
Yeah, someone had a doubt in practice. We finish that and then we come back to you.
Okay, madam.
So, who had a doubt in practice?
Yeah, ma'am. Ma'am, on 8th question.
Eighth question, yes.
Ma'am, actually it is asking us find the first row of P plus Q plus minus R, but we have also another unknown variable C.
Okay.
It is easy to determine C from the 9th question. They given the determinant answer, so it is easy to calculate the C. But without the determinant A, how to find the C unknown?
Did you check the solution? No, it's not yet uploaded, is it? Yes. it's not there. Okay, we'll upload the solution to this practice assignment because I think it will take some time to solve if I sit to solve.
Okay.
Yeah, we'll upload the assignment solution.
Ma'am?
Yeah.
Ma'am, can I ask?
Yeah, sure, please. Sir.
Madam, can we multiply with non-zero constant with the system of linear equation? Then output is generate 3 times of previous old output or not, sir?
So you're asking,
If
you
we
have ax is equal to b, and then what are you doing?
if we multiply non-zero constant with the system of linear equation, then
right?
yes.
This is what you're asking, huh?
Then it is output is the same as the old output, na madam, solution.
Yes, no, you can just cancel the c out, no?
Okay.
You have
Okay.
x plus y is equal to 1, x minus y is equal to 0. So instead you're doing 2 times. And you can just cancel out that 2 and still you'll have the same solution, right?
Okay, madam. Got it,
So,
madam.
but
Ma'am, how to find adjugate of adjugate matrix, ma'am?
How will you find the adjoint matrix?
Adjoint. Adjoint of matrix.
How will you find the adjoint?
1 by determinant of 1 by
No, that is inverse.
transpose of cofactor.
Transpose of the cofactor matrix. So adjoint of adjoint will be find the cofactor matrix for the adjoint matrix and then find it. But why are you doing all that? Is it
One
determinant
question
of
was
this or
there,
something?
madam. One question
Determinant
was
of this, is it?
Ma'am, I don't remember the question. I will check and come back, ma'am.
This has some formula, no? Adjoint of adjoint is what? Determinant of a power n minus 1
Whole square, I think.
Power n minus 1 it will be. If a is n cross n, then it will be power n minus 1.
Is it not n minus 1 whole square, ma'am?
Okay, maybe. I don't remember the formula exactly.
I think
So
because
maybe
two
something else.
times adjoint is there, I remembered like it's n minus 1 whole square.
Okay.
but ma'am, there is this formula in the lecture. It is not given.
Adjoint of A is no, A into adjoint of A is
That
determinant
A
of
into
A
I.
into identity. So the determinant of this will be power n times this. So determinant of adjoint will be right. Determinant of A power n minus 1. Right. Then it must be square. There's some formulas, so you can just use that and find.
तो डिस्टेंस ज्यादा तो सिमिलैरिटी कम तो डिस्टेंस ज्यादा, ठीक है? तो हमें कोसाइन डिस्टेंस निकालना है हर दूरी का, ठीक है? तो
Parag, can you please mute if you're not talking to me?
फंक्शन है हमारे पास साइड में, उसको बोला जाता है कोसाइन सिमिलैरिटी और हमें यहां पे मिलता है कोसाइन सिमिलैरिटी.
Then, any other doubts?
Ma'am, I have a doubt.
Yes, please. Amrita, do you have doubts in these two questions?
Yes, ma'am. Activity question 1.2
Yeah, okay.
10th
So
and
shall we
1.
finish the previous doubt and then come
Yes,
to this?
ma'am. Yes, ma'am.
Yeah.
Ma'am, I have doubt in activity question 1.5 in the first question.
Okay.
Here in the fourth option, it is given that submatrices can be of all possible orders, and the 3 by 3 order is also included.
You can consider the matrix as a submatrix of itself. So that's okay.
Oh, okay.
Every set is a subset of itself, no? Like that.
Okay.
Yeah. Yes, Amrita.
Yeah, it is activity question 1.2 or 10th question. One second. Yeah, here I tried to solve this matrix, but my answer is coming as -1.
Okay, so what's the problem?
So the
Answer is not
answer is
-1.
actually I did find the value of a square by multiplying the matrix A by A into A. Then A square is A. Here I tried to consider a matrix, but then here the value of alpha is not coming as what it is given in the answer. Can you just tell me the approach how to solve this?
You just have to do that. Find out a squared, find out alpha times a, identity matrix, add all this, put equal to 0, whatever alpha you're getting, that will be the answer.
Okay, that's what I did, but the answer which is the activity question showing is not matching with my answer.
What is the matrix? 1, 2, 4, 7, minus 1, 0. Minus 1, 2, 4, minus 4, 7. 1 minus 8, minus 2, 14, 4 minus 28, minus 8, 49. Now what's that?
So it's minus
Okay.
7, minus 24, 12, and 41.
41. Okay, fine. And then you have to add minus alpha a. So minus alpha a. Plus identity. This is equal to 0. So pick any one relation, that's enough. Minus 7 plus alpha plus 1 is equal to 0. So alpha is 6, right?
Okay, here only we have substituted the matrix and solved it. What I did, I found the values of individual things and then I solved it.
That's okay, no. But what is the value of this? You don't know alpha, no?
Yes, yeah. Okay.
So is this method clear? Like, this will
Yeah,
you do
the
it.
method is clear.
Excuse me, ma'am.
Yeah.
Ma'am, I solved this question already, but how you solved it very short.
How did you solve it?
Means in the last line, over how you find minus alpha, minus 7 plus alpha. And
I just solved the matrix. It's all equal to 0, right? So what is the sum? Minus 7 plus alpha plus 1. 12 minus 2 alpha plus 0. Minus 24 plus 4 alpha plus 0.
okay.
41. Huh.
Okay, you added all three matrices.
This is equal to 0, 0, 0, 0. So you have to put any one entry to 0, you will get the answer. Amrita, you had another doubt also, right?
1.5, last question, 10th question. So here, are we supposed to solve directly by putting the value of determinant because answer here is 12, but somewhere I'm getting the answer in decimals. A square, yeah. The value of determinant A is 4. Yeah.
What is B?
B is 3 times A.
So you put that here first.
Okay.
Determinant of 3a cube. What is determinant of 3a cube?
Okay. So 3A naturally will be 12 and the answer will be 12. Yeah. Got it, ma'am.
Okay, 3 times determinant of a. Okay. Any other doubts?
There is one problem in the triangles wherein the three vertices of 1.4, not 1.5, 1.4, the three vertices of the triangles are given. I believe, yeah.
Formula is also given.
6 and
You
7.
just have to
Formula is
substitute.
also given, So here, when we substitute it in the formula, so it's A into X. So we get the matrix as -1, determinant as -1, 1, 1, 1, 1, 0. Only 1 0 is there and rest all ones are there. But then the answer comes out to be -1, and the value of the triangle or the area of the triangle is given as 1. So is it like we have to ignore the minus sign and the answer would be 1?
Yeah, it's
Mod
given,
is
no?
given.
Half times mod determinant of D.
Okay, okay, okay.
Mod.
Yeah, I just understood that now. And on the similar lines, we have given 3 vertices in the 7th question, wherein the area of triangle is given. So, how do we approach this question? Means I didn't even understand how to solve it.
You have 3 vertices, and if you're given
Okay.
3 vertices, you know how to solve the
Again, the same
determinant,
method
means
has to be
find the area.
followed. Okay, fine, fine, fine. I'll give
Yeah.
it a try.
I think you'll get 2 values of x, but x greater than 0, so you pick that one.
Okay, okay. Thank you.
Any other doubts?
Ma'am,
Question
please
number
open
14th
your
of
note.
graded solve with us.
I'm not a physics student. I finished my PhD from IIT Madras. I finished a year back. Yeah.
Ma'am, open your note, ma'am, notebook where you were writing. And the adjoint of adjoint, I didn't get, but I'm still trying. Above
Okay.
scale of ma'am, scroll
But ma'am,
here,
is it
here, ma'am.
in the syllabus?
This is in week 2.
One question is there adjoint of adjoint, that's why. Ma'am, I
Week
didn't
2,
get
right?
date of. Yes, ma'am. Week 2, I don't remember, but I saw in the folder.
Yeah, adjoint comes
Date
in
day
week 2.
n-1 whole square.
I don't know. I'm not sure about this formula, but yeah, I think we can calculate it. Determinant of adjoint of A, the P equal to what is determinant of adjoint of A is this. So determinant of adjoint of A will be determinant of adjoint of A power n minus 1. Yeah, it's determinant of A power n minus 1 whole square. Right. You can use this as a formula.
Wait, ma'am, I will write down.
I think it is there, no? Solve with us or something.
Will you upload this notes, ma'am?
Yeah.
Okay, ma'am.
Okay. If there are no other doubts, then maybe we can close the session. Solve with us question 14. Question 14. Yeah, what is the doubt in this?
I've tried to solve this with the help of an example. Like I've taken some matrix to solve this, but here can we take like as you mentioned that every time we have to take one example to just prove the thing, and if we have to disprove, we just need one counter example.
Yeah, to prove you have to take something in general. You shouldn't pick numbers.
Okay.
This is straightforward, right? You know determinant
Yeah.
of A, B. Yeah.
Actually, all the properties are clear. But then, for example, when we get an exam, we are not able to remember all the properties. So somewhere we can quickly, if you can give us a tip, like how to check, because there are a lot of theoretical concepts are there which might come in exam, and that's wherein we cannot draw the matrix and keep checking everything.
So if you remember these things, that should do. All these. Determinant of a power n is equal to determinant of a whole power n, and then this. Product is this, transpose is this, inverse is this, power is this. Sum, it doesn't become like, means it doesn't spread. So that's it. With this, you can solve all the problems.
Yeah, thank you. Thank you.
Thank you, ma'am. Ma'am, you just posted one G form link, right? Can you just post it again? I couldn't open it.
Yeah. Done. Okay, then I guess we'll stop.
Hello, ma'am. I have a doubt in activity question 1.3, question number 3. I earlier asked this, but I didn't get it. So.
Okay.
In that C into AX is equal to B. I am not getting it. Actually, I asked it earlier, but I didn't get at that time.
C into AX. Third option, is it? If
Yes.
AX is equal to B is a system of linear equations which has a solution. Then the system of equations C is equal to AX plus AX is equal to B will also have a solution. Okay. So you have AX is equal to B has a solution. So there is some X which satisfies AX is equal to B. Now you are multiplying the system, the coefficient matrix alone with B, with C. C is a non-zero number.
Yes.
And then what can you tell? From here, how can you associate it with AX is equal to B?
No, ma'am, I am not getting it. That's it.
You can write it as AX is equal to 1 by C times B, right?
Yes.
So what is the question? If AX is equal to B is a system of linear equations which has a solution, then system of linear equations this will also have a solution. Is that true?
Yes, it is true.
So how do I tell that with week 1 content? Can you construct a solution? If you can construct a solution, you are done, right? Means you want to check whether this has a solution or not. If you can construct a solution, you are done, right?
Yes.
So what about 1 by C times X? C times A of 1 by C times X. What is this?
No, ma'am, I'm not getting. What are you?
No, I'm multiplying. I already know, say y is the solution. Or let's not call it y. Say, okay, say y is the solution to this. I know this already has a solution, right?
Yes.
AX is equal to B. So say that solution is y. This is my solution. Okay.
Okay.
Now I'm telling you, you have that y which is a vector, right? You multiply that by 1 by C.
But why 1 by C? From where you take that?
No, I am trying to somehow construct a solution for this system. I want to find a solution that fits into this.
Okay.
So what is this? Means I am multiplying by a number. I can take that number out, right? Like I can take it out of the matrix as well, right?
Yes.
So it's going to be C times 1 by C, AY. What is
Okay.
this? What is
C
AY?
cancel. AY is equal to B.
So this is a solution, right?
Means
1 by C times Y satisfies CAX is equal to B. Yes or no?
means we know that AY is equal to B, and we are again getting AY is equal to B. That's why you are saying.
No, I am not getting AY is equal to B. I am using that AY is equal to B here. And then I am getting CA 1 by C times Y is equal to B. So this is my solution, right?
Yes.
Because in the place of X, I have put that.
Yeah.
So I have found the solution to this system. Agree?
Then we can put anything in that place.
No, if you put anything, it is not guaranteed you will get B, no?
No.
You should get B. I am getting that B because I know AY is equal to B.
Okay.
Yeah.
Okay.
Okay, then I guess we'll close if there are no more doubts.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you,
ma'am.
Thank you.
Thank you.
Hello.
Yeah.
Ma'am, there is no doubt from mathematics. There are many people from all over India. I want to ask, have anyone witnessed a star, a line of stars like thing going in sky?
I haven't noticed.
Today I have seen something 10 to 15 stars going in a line. I don't know what it was.
Oh, and you're from which part of India? Like which state?
I'm from Hisar, Haryana.
Acha. I haven't seen. I'm in Chennai. I haven't seen.
Ma'am, I have just one doubt. Can you please explain?
Yeah.
So, ma'am, it is a practice assignment 1, question number 2.
Okay.
And I can broadcast it?
I don't think you'll have the permission to do that. Yeah. Tell me. Can you see my screen?
Yes, ma'am.
What is the
Question number
doubt?
2. Yes, ma'am. Ma'am, I have done this question and got 0.75 for this. I don't understand. My answer was correct for first option, second option, and third option is correct also, but I don't understand how it is.
Okay.
And I marked also fourth option. So one of my option is incorrect and one is left out. I think all the options are correct, right?
The number of scalar additions to be done to compute the matrix where A is equals to and B is equals to. All are correct, okay?
Yes. Third option. Please explain third option.
0 to 2 0.
2202.
0. You want to find the 10th power. So first let's find the second power. 2202. Determinant or the matrix itself? The matrix itself. Okay. Okay, before that, can I write this as 2 times 1101?
Yes.
Now let's compute. So the power 10 will be 2 power 10 into 10th power of this matrix, right?
Okay.
So 1101. What is the square of this matrix?
The square comes out to be 2 to the power 2, 1021. Yeah, 1201.
What is the third power?
2 to the power 3.
1301.
2 to the power 3, 1301.
Huh.
So
Can you see that there is a
10 to
pattern?
power. Yeah.
Yes, ma'am.
So the 10
Okay.
powers will be 1.
110
Power is
01.
110, 01, 2 to the power 10.
Yeah.
Okay. Thank you, ma'am. I have this
Yeah.
doubt and one more doubt.
Huh.
Question number 3, ma'am. Same.
Okay.
In question number 3, first and second option is correct, right?
No. Why is second correct? You cannot add determinants like this.
It is not multiplied.
Is the sum of the first and third row? No, second not.
This is wrong.
Why
Yes.
first?
Huh? Second option is wrong, right?
Second option is wrong.
Huh.
And I'm checking my answer. Just a minute.
Okay.
This is correct. Okay, this is sorted actually.
Okay.
If there is anyone. Yes, ma'am. Comprehension type question. I actually I did this question. First question comprehension type. So my answer came out to be 13.
Okay. The answer is 5.
Yes, answer is 5.
We'll upload the solution. You can check with that.
Okay, ma'am. Okay.
Ma'am, are we going to get some resources from the instructor or something like that?
No, you have the solve with us, no? That itself has all the summary of the entire week.
Yes,
And
we used to have a PDF kind of a thing where we have all the properties, all the solving things, everything in the same place, so we can use
so
for
in Maths 2, the equivalent for that is solve with us. So you just take the solve with us, you get everything that's needed for that entire week.
Okay.
It has all the contents as well, right? A quick recap of the contents and problems.
Are we
And
going?
it is very helpful.
Are we going to get the practice assignment solutions also by tomorrow?
No, actually, it should be up by now. I'll just remind and we'll put it now.
Okay, because tomorrow is our graded assignment.
Yeah.
Okay. Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you.
Thank you, ma'am.